Trigonometry is the study of right-angled triangles. And a right-angled triangle is effectively any triangle where one of the angles is a right-angled triangle or one of the angles is 90 degrees. In this case, the 90-degree angle is here. The most important step in trigonometry is to be able to label the sides of your triangle. The length, which is directly opposite the 90-degree angle, is always called the hypotenuse, or the h. And the hypotenuse is basically the longest length in your right-angled triangle. And the hypotenuse is always opposite the 90-degree angle. It's the length the 90-degree angle looks at. And that is the most important length in any right-angled triangle. And in terms of labeling, that is the length that you have to get correct. The other two lengths in your right-angled triangle we call the opposite side, or the O, and the other side we call the adjacent side, or the A. Alternatively, and more commonly, the hypotenuse is commonly labelled little c. It's always little c. And the other two lengths, the opposite and the adjacent, are commonly called A and B. Now remember that A and B are the lengths in your right-angled triangle. Now it doesn't matter which length you call A and B, so we could interchange the A and the B. But it's important where we get the hypotenuse. So we can replace the A and the B, we can interchange the A and the B, but the hypotenuse, or the C, is the length which is opposite the 90-degree angle. When you start any problem, you always start by labeling the hypotenuse first and getting the C in the correct place. And that length is always opposite the 90-degree angle. Pythagoras' theorem is the first theorem that we're going to look at in trigonometry. And all Pythagoras' theorem is it represents a formula. Now, sometimes the formula is written as hyp squared equals op squared plus h squared. But the key thing with the formula is that it basically just represents the lengths in your right-angled triangle. It's a relationship between the three sides of your triangle and how they're related to each other. So the length of the hypotenuse squared is equal to the length of the opposite squared plus the length of the adjacent squared. It's a formula that you will just have to remember. You'd no longer get that in the formula sheet. Conveniently, rather than using the terms hyp, op, and adj, remembering that the hyp is C, we can rewrite this formula as C squared equals A squared plus B squared. And this may be more familiar to a lot of people. But all Pythagoras' theorem is, it's basically and nothing more than an equation linking the three sides of your right-angled triangle. Using Pythagoras' theorem is fairly straightforward. So if we start off by writing the theorem at the top, C squared equals A squared plus B squared. We're going to look at two worked examples where we apply this formula or this equation to solving a problem and working out a given length. Now, the first thing you do with any question that you get with a right-angled triangle, you read the question. We want to work out the length, which is x in this case. The 90-degree angle in this triangle is located here. That's your 90-degree angle. The first thing we do is we label the sides. So the length which is directly opposite the 90-degree angle is what we're going to call C. Now, it doesn't matter which two lengths we call A and B. So I'm going to call this length here, the 8 meters A, and I'm going to call the other length, the adjacent side, B. But remember, it's completely arbitrary. We could interchange the A and the B. The most important thing is to get the hypotenuse or the position of C in the right place. The first thing you do with any mathematics or with solving any question is you always start by writing down the formula that you're going to use. In this case, because we're using Pythagoras' theorem, we're just going to write down the formula. C squared equals A squared plus B squared. The next thing we're going to do is we're not going to do any calculations. All we're going to do is look at the diagram and then replace what we know in the diagram into this formula. So we know that C is equal to X. So I'm going to replace this C with X so that I get X squared equals. Now looking at the diagram, I know that A is this length here, which is the 8. Now I'm not going to worry about the units or put the units in the formula. I'm just going to put the number in. So I'm going to replace the A in the formula with 8, but I'm going to replace the 8 in a bracket. Plus, and then the B from the diagram I know is 6. So that's 6, that's B. I'm going to replace the B here in the formula with the number 6 in a bracket. And then what you do is you just type the whole of the right-hand side. So the whole of this is basically just typed into your calculator in one go. If you do that, you'll find that X squared is equal to 100. Now, when you're doing this in your calculator, just make sure that you include the brackets. So X squared is equal to 100, and then the final step to get rid of that square, you're going to take the square root. The opposite of squaring a number is taking the square root. So if we do that, the square root of 100, again, you can use your calculator to work that out. You're going to get X is equal to 10. And then at the end, I'm going to put back the units. In this case, it's going to be meters. And that is what your final answer is going to be. Now, the key thing to remember is how you're actually setting your work out. You always start by writing the formula. You then substitute or replace the letters in the formula with the numbers that you know in the question. And you keep everything logical, and you keep everything on a new line, and you keep everything spaced out. If you make any mistakes, you're going to be able to spot them very, very easily. The next example of how to use Pythagoras' theorem is done in a very, very similar manner. What we have is we have a right angle triangle, and like in the previous case, the right angle triangle, or the 90-degree angle rather, is here. The first thing you do is you start by labeling the hypotenuse, the C, the A, and the B. Remember, the hype, or the C, is always the length which is opposite the 90-degree angle. So the length that the 90-degree angle looks at is what we always call C. It doesn't matter which length we call A and B. So the other two lengths of our triangle here and here, we can label them independently A and B. So this time what I'm going to do is I'm going to call this side B, and I'm going to call this side A. If you wanted to interchange it, you could. Like the previous example, the first thing we do is we start by writing down the formula for Pythagoras' theorem. And we're not going to work anything out, but what we're going to do is in this formula, we're basically just going to replace what we know from the diagram. Now we know that the C is 16, so I'm going to replace the C here with 16. Now I'm not going to change anything in the formula. I'm just going to rewrite it, putting in the values that we know. So C is equal to 16. The A from the diagram, well, I know that the A here is 5 meters, so I'm going to replace this A with a bracket with 5, like so. So I'm getting used to using brackets. And then the B this time is the X, which is here, which is what I'm trying to work out. So I replace the B with X, and I've got the squared. The next step is a little bit of algebra. To get this x squared on its own, I'm going to move this 5 squared term over to the left-hand side of the equation. I'm going to move it over here. Now, this is where a little bit of algebra comes in. If you move anything over the equal sign, the operation changes. So this plus 5 squared, when it goes over, becomes minus 5 squared. So on the left-hand side, we're now going to have 16 squared. Now, the 16 squared stays as it is because we haven't moved it. We're then going to have minus 5 squared equals x squared. Like in the previous example, I'm just going to type in the whole of the left-hand side into the calculator as I've written it. So if I bring up a calculator, I'm going to type in the whole of the left-hand side exactly as I've written it using brackets. So I'm going to open a bracket, 16 close bracket squared. As you can see, I'm using brackets to put the 16 in, minus open bracket 5 close bracket squared, and I get a value of 231. So x squared is going to be equal to 231. So I can write x squared is equal to 231. And then to get x, all I need to do is to take the square root of 231. Again, you can do that on your calculator. And if I bring the calculator back up again, I can take the square root of 31. If I clear that, you press the square root button first, and then you type in 231. And your number comes up, your answer comes up. It's 15.198684. So on. I want this to one decimal place, so I look at the second decimal place, which is that 9. Now, because that 9 is bigger than 5, the 1 which is directly next to it, I have to increase by 1. So my answer is going to become 15.2 to one decimal place. So my final answer is going to be 15.2, and I'm going to put the units in, which are the meters, and that is my answer. For the time being, I'm not worried about decimal places or significant figures. The main point to get across is how you're actually laying out your work. You always start by writing out the formula that you're using. Always. You then set everything out on a new line, and you keep everything spaced out, and you keep everything logical.